Okay, so this is an introduction to vectors. Vectors are quantities that have a magnitude and a direction. So we might talk about 50 meters per second. Someone's traveling at 50 meters per second. That doesn't tell me what direction they're traveling. Then we say 50 meters per second south. That gives me a magnitude and a direction. So the magnitude is the size, and the direction tells me what direction they're traveling at. We would normally represent a vector as an arrow. So here's a vector going from A to B. So we can represent that as AB with a little arrow over the top, or sometimes we'll represent that as vector A with a tilde. So a vector always runs with a magnitude and a direction. Now two vectors are the same if they're parallel, that is they're going in the same direction, they have the same magnitude and the same direction. So we would say vector A equals vector B. A negative vector would be one that's going in the same direction, it's running parallel, it's the same size, but is in the opposite direction. So A and negative A. Negative just means it's the same size, but it's in the opposite direction. The other concepts that we're looking at are a zero vector. A zero vector obviously just goes nowhere, a null vector. It starts and finishes at the same spot. We're multiplication by a scalar. Multiplication by a scalar. So if you have vector A times that by 2, that's the same as just A and A, join it together, there's 2A. It's just twice the length. So multiplication by a scalar gives me 2A. The other thing that we can look at is a position vector. And when we're talking about a position vector, we're always talking on a Cartesian plane, a Cartesian space. So here's somewhere there, we're thinking about relative to the origin, there's our position vector. It goes from the position vector of A to O. Let's say that was the vector OA. That's our position vector. Position vectors always start at the origin and go from the origin to the point. Now sometimes, let's say that point was 3, 2, we would say that as an ordered pair, 3, 2. We've gone across 3 and up 2. Haven't drawn that very accurately, but you sort of get the point. Now the difference between a position vector and just a displacement vector, here's that same vector going across 3 and up 2. I'm obviously a little bit out of scale, but it just goes from A to B. It's a displacement vector. It can go from any point to any other point. It doesn't have to start and finish at the origin. Position vector must start and finish at the origin. Okay, and that's the end of this video.